Hello everyone, how are you? Welcome you all in my YouTube channel. So today we are discussing the new topic of chemical thermodynamics. The topic name is Poisson equation. Okay, what is the Poisson equation? And this equation are also related with the adiabatic relation. Okay, adiabatic process. In that equation, in Poisson equation, we are mainly discuss the relation between the pressure, volume, temperature with respect to the adiabatic process. Okay, and that process is known as the Poisson equation. Okay, first we write down the Poisson equation is related to the adiabatic process. Okay, is also the part of adiabatic process, correct? And the relation between pressure, volume, temperature with respect to adiabatic, okay, is known as Poisson's equation. Okay, you already know the what is the Poisson equation. Poisson equation is nothing but the relation between the pressure, volume, temperature with respect to the adiabatic process. Okay, there are some condition will be there for Poisson equation. What are the condition for Poisson equation are? There are three condition. Main condition will be there. Okay, you can write down the condition of Poisson equation. The first condition is the process should be adiabatic. Okay, adiabatic process should be there, correct? This is the first condition. Second condition is the whole process should be reversible. Okay, whole process should be reversible. And the third is the main condition will be the ideal gas is mandatory. Okay, ideal, in the presence of ideal gas you only find the relation between the pressure, volume and temperature with respect to adiabatic. Okay, uh, either than ideal gas, like you can take the van der Waals gases, you can't find the relation between the pressure, volume and temperature with adiabatic, okay, processes. Now using the first law of thermodynamics we can also prove the value of Poisson equation. What is the formula of Poisson equation with the help of first law of thermodynamics? Okay, now here we can express the formula for Poisson equation with the help of first law of thermodynamics. Okay, the first law of thermodynamics. Thermodynamics. The first law of thermodynamics states that uh, the internal energy is equal to charge multiplied by work. Okay, or you already know in adiabatic processes there is no heat exchange will be there. That's why you can write down in the place of q, okay, is 0. The value of q will be 0. Charge are not transferred from the one system to the another system, or not transferred inside or outside of the system. Okay, and the value of delta u should be the w. Okay, this is the value of first law of thermodynamics in adiabatic processes. Okay, now we know that the delta u is also written as n cv dt is equal to, and w is written as p external dv. Okay, p external plus dv. In the place of n cv dt is equal to, can I write in the place of P external, in the place of P external, can I write down the P internal? Because in the reversible reaction, the P external and P internal, both the value are same. Okay, here I can write down in the place of P external is P internal. Okay, and the value of NCV dt is equal to minus P internal dV. Okay, this is the equation for first law of thermodynamic in adiabatic processes. Okay, the second is you can simply integrate this entire equation. Okay, simply you have to integrate this entire equation, and Cv dt is equal to minus integration of P internal dV. Okay, in that integration, those value are constant. You have to put outside of the integration, and Cv integration of dt. Okay, integration of dt upon t, okay, is equal to minus integration of PV value. Value of PV is, okay, in place of PV you can write down the nRT. Okay, here nRT divided by volume multiplied by dV, correct? And you can simply integrated this entire value, and Cv, okay, here the value of dt upon t is log e t2 upon t1, okay, minus integration of nRT, and the constant value is put outside of the bracket. What is the constant value? N R, okay, and nr, and in integration inside the box is dv upon volume. Okay, and after integration you can find NCV. Integration of dt upon dt is ln t2 upon t1. Okay, this is the first, and second integration is nr ln v2 divided by v1. Okay, can I simply cut down the value of n, because in both the side n will be the same. Okay, now the equation after removing the n from this equation, Cv ln t2 upon t1 is equal to minus r ln v2 divided by v1. Okay, correct? Now you already know that Cv ln t2 upon t2 we can also write down in the place of Cp minus Cv is equal to R. Okay, in the place of R, can we write down the value of Cp minus Cv? Okay, I can also write down the in the place of R, Cv ln t2 upon t1 is equal to, in the place of R I can write down the value of Cp minus Cv. Okay, so simply the Cp minus Cv divided by Cv, okay, ln v1 upon v2, because if we interchange the value of v2 upon v1, the negative sign will be removed. Okay, the next procedure is you can cut down Cv from here. You can see the Cv and Cv is cutting. Okay, cut down from here. Now the value of ln t2 upon t1 is equal to Cp upon Cv, okay, minus 1 ln v1 upon v2. Okay, ln t2 upon t1 is equal to, you already know the value of Cp upon Cv is gamma. Okay, this value is found in thermodynamic in previous lecture. If you want the previous lecture, you can go to the YouTube and search thermodynamics lecture of study text boards mania. You can find the several number of video. In that video, I already discussed the coefficient of thermodynamics like alpha, beta, and gamma. Okay, and the value of gamma is Cp upon Cv. Simply I can write down in the place of Cb upon Cv is gamma minus 1, correct? ln v1 upon v2, okay, in the place of cp upon cv, okay. Here ln t2 divided by t1 is equal to ln v1 divided by v2, okay. You can see here one derivative formula is using here, okay. Which formula are used in that equation is, if you remember, the I have one formula for derivative is ln ax, okay. You can simply write down this whole equation into this, okay, x ln a, okay. Now you can see here the value of x will be the gamma minus 1. Can I write down on power v1 upon v2, okay. Yeah, I can write on the power of v1 upon v2. The value of ln and ln is cut because both the side the value is same. Now here only left is t2 upon t1 is equal to v1 upon v2, okay, power gamma minus 1, okay. And this is the equation of first law of thermodynamics with respect to the Poisson law or with respect to the adiabatic process, okay. But we already know the value of v1. You can also write in place of v1 is v2, in place of p1 is, we also write the value of p2, okay. If I have the value of v1 upon v2, okay, can I write down in the place of v1 upon v2 p2 upon p1, okay. We also write down in the place of v1 upon v2 is equal to p2 upon p2. Here you can simply cross multiply and the value is t2 v2, okay. And in v2 the gamma minus 1 will be there is equal to t1 v1 gamma minus 1, okay. And this is the final equation for first law of thermodynamics in Poisson's equation, okay. And from this equation you can find the relation between the pressure, volume and temperature, okay. Now the first point, the first subtopic in this is relation with pressure and volume, okay. What is the relation of pressure volume in adiabatic processes or in Poisson's equation, okay. We already found the value of value of Poisson's equation is T2 V2, okay, gamma minus 1 is equal to T1 V1 gamma minus 1, okay. In the place of uh, in uh, in relation with the PV, we already know the value of PV is equal to nRT, okay, for using ideal gas, correct. If we use the ideal gas equation, we already know the value of PV is nRT, okay. In the place of PV is equal to nRT, you can easily write down, okay. And the value of T is PV upon R, okay. I can simply remove T from here and write down the, in the place of T, PV upon R, correct. Can I write down the PV upon R because relation with the P and V, you can here see that the temperature is not there, okay. The temperature is not there, it's mean the temperature is constant, okay. And that temperature is, if the temperature is constant, uh, in the place of in the place of T, I can write down the value of PV upon R, okay. And the equation will be converted like P2 V2, okay, gamma minus 1 is equal to P1 V1 divided by R gamma minus 1, and here also divided by R, and whole equation is multiplied by V2, and here the whole equation is multiplied by V1. Okay, R will be cut, and P2 V2, okay, outside the bracket is V2, is gamma minus 1 is equal to P1 V1 multiplied by V1 gamma minus 1. Okay, and this equation is P2 V2 gamma is equal to P1 V1 gamma. Okay, and this is the value of, this is the relation between adiabatic process and pressure and volume, okay, at constant temperature. Correct. Now the next relation is pressure and temperature. Second relation with pressure and temperature. I have a value of Poisson's equation. The Poisson equation is T2 V2 gamma minus 1 is equal to T1 V1 gamma minus 1. Correct. In the place of pressure, okay, we can write down, because we already know here the volume are not present. Okay, so in the place of volume we can write down another value. We already know the value of PV is equal to nRT. Okay, V is equal to nRT upon pressure. Okay, correct. In the place of V, I can write down this equation, this value. Okay, and T2 in bracket in the place of V2 are T2 divided by P. Okay, P2 gamma minus 1 is equal to T1 R T1 divided by P1 gamma minus 1. Okay, and here the P2 1 minus gamma T2 gamma, okay, is equal to P1 1 minus gamma T1 gamma. Okay, and this is the equation of relation between the pressure and temperature at constant volume. Okay, now we can see some questions, some example related to the Poisson's equation. First question is, first I can write down the question, then we can discuss the answer. Okay, now you can look here, the question is written here. 1 mole of ideal gas will be given. The value of Cp is also given, 29.3234 joule per kilomole, is expanded reversibly and adiabatically from 1 dm cube to the 10 dm cube of the initial temperature is 750 Kelvin. Find the final temperature. Okay, if you find any question in your exam, in your in any, okay, any condition, first write down the given value. Okay, what is the given value? Given value is, inside the question there are some information is already mentioned. That information first write down. The value of n is equal to given is 1. Correct. The value of Cp is also given, 29.234, okay, joule per kilomole. Correct. A whole process is a reversible process. Okay, and the value of V1 is also given, 1 dm cube. Correct. The value of V2 is also given, is 10 dm cube. Value of T1 is also given, is 750 Kelvin. Okay, and this is the initial temperature, and value of T2 is find. Okay, and this is the final temperature. With the help of this information, we have one equation and this equation is Poisson's equation. What is the Poisson's equation? T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. Okay. In the place of T1, we can write down the value of T1 is 750. Okay. Multiply by, in the place of V1 is 1 dm cube. Okay, the gamma value is, how to find the gamma value? Gamma, the formula of formula for the gamma is Cp upon Cv. Okay, in coefficient of thermodynamics, we discussed the alpha, beta, and gamma, and you can also write Cp minus Cv is equal to R. Correct. What is the value of Cp? The value of Cp is 29.234. We don't know the value of Cv. The value of R is equal to universal gas constant 8.314. Simply you can find the value of Cv is 29.234 minus 8.314 is equal to Cv. Okay. And the value of Cv is 20.92 is equal to Cv. Correct. And the value of gamma is 29.234 divided by 20.92. Okay, and the gamma value is around 1.4. Now you have a gamma value. Simply you have to put the gamma value here. What is the gamma value? Is 1.4 minus 1 is equal to, what is the value of T2? You have to find the value of T2. What is the value of V2? Is 10. Okay, what is the gamma value? Is 1.4 minus 1. Correct. 750 multiplied by 1 is 0.4 on power divided by 10 to the power 0.4 is equal to T2. Okay. Now the value of T2 is around 750 divided by 1 upon 10, 0.4 is equal to T2. Okay. And the value of T2 around 300 Kelvin. Okay. And this is the answer for this question. Okay. I think you already understand the whole topic. What is the Poisson's equation? I already given all the information about the Poisson's equation. We also solve the numerical, also solve the question on based on the Poisson's equation. If you still find some doubts or you don't understand any point, please comment down, and you can also contact me on Instagram and Telegram. Okay, and please do not forget to subscribe my channel, and you can also share with your friends also. Thank you so much for watching my video. See you in another video. Thank you.